Right, integration. This chapter we're going to be integrating standard functions, and we're going to be looking at integration as the reverse of differentiation for these functions. So hit pause, copy the lesson objective down. When you're ready, hit play, and we'll move on, move forward. Right, let's look at some of these standard functions which we've differentiated. So we're going to be looking at these standard functions which we've differentiated, and we're going to look at the derivatives, and the reverse of differentiation is our integral. So if we look at f of x and we say f of x is equal to sine of x, now when we differentiate sine of x, we get cos of x. So if we were to reverse this process, so in reverse, if we were to say that f of x is equal to cos of x, then we want to integrate this function of x, f of x. So to integrate then cos of x with respect to x, we get the reverse. We get sine of x. And there's something missing. Is that constant? Always got to remember to put our constant in. So this is a standard function, and we've reversed it. So hit pause, copy this example down. Once you've done that, we'll have a look at another one. So here's another function we can look at, log of x. So f of x is equal to log of x. Now, if we were to differentiate f of x, so f dash of x, we get 1 over x, which you're familiar with. Now we can reverse this process. So if f of x, our function, is equal to 1 over x, and we wanted to we wanted to integrate f of x, so the integral of 1 over x with respect to x, we get log of x. But we can't forget our constant. However, we've got to remember with log of x that we've got to use our modulus sign, because it's got to be positive. We can't have the log of a negative value. Okay, it doesn't exist. If you remember from our graph of log of x, quick sketch, it tends to 0 there and branches off like that. Always positive. The values of x. Okay, right, so hit pause, that's another standard function. Copy the example down. When you're ready, hit play, and we'll look at another one. Okay, so this is a nice example of a definite integral. So what we want to do is we want to integrate between -3 and -2, 1 over x, with respect to x. And we'll do the integral first. If we integrate 1 over x, we get log of x. And it's our definite, it's our modulus, and that's between -3 and -2. So we sub from -3 and -2 in here, so log of the modulus of -2 minus log of -3, which is, it's got to be positive in the modulus sign, so log of 2 minus log of 3. And we can work that out on our calculator, and you should get 0.401 minus 0.41 to 2 decimal places. But remember, we're integrating, so we're finding the area under a curve, so we've got to have a positive solution. So our solution is going to be 0.41. Okay. Hit pause, copy the example down. Once you've done that, hit play, We'll look at another example. Okay, so here are a few more standard functions and their derivatives. So you got tan of kx. If you do, its derivative is k sec squared kx. Sec of kx, you get k sec kx tan kx. Cot of kx is minus k cosec squared kx, and cosec kx is equal to minus k cosec kx cot kx. What you tend to do with, well, in this chapter and for a bit, is we tend to look for these terms. If we can find these standard functions, then we've got to recognize that their integral is the reverse of their differential. So we reverse the process. So if we spot these terms, we can reverse the process. So those are good standard functions for you to keep a note of. Like it says, you're not given these in the exam, so you need to be able to derive them in the first instance to know what they are. Right, hit pause, copy these down. Once you've done that, I've got a couple more. Okay, so I think these 9 standard functions are ones you need to make a note of and recollect. And they're written in the correct way, I suppose, for integrals. So we're showing the integral of these functions. Hit pause, copy these 9 down. When you're ready, we'll have a go at an example. Okay, so we've got a nice example here. We've got our standard functions. We're lucky we have them displayed for us here. Right, so let's have a look at this example. I want us to integrate 2 cos x plus 3 over x minus the square root of x with respect to x. So let's have a go at doing that then. So we've got the integral of 2 cos x plus 3 over x minus the square root of x with respect to x. Now, I can simplify that square root of x, make it easier for me to integrate. So that's going to be the integral of 2 cos x plus 3 over x minus x to the power of a half with respect to x. And we go term by term integration. So 2 cos x is going to give me 2 sine x plus 3 over x is going to give me 3 log modulus of x minus, I need to add 1 to the power and then divide by that. So adding 1 gives me 3 over 2, and dividing by 3 over 2, I've got write the reciprocal of 3 over 2 is 2 over 3, x to the power of 3 over 2. And we must never forget our constant term. Okay. So term by term integration. These are standard functions. Cos gives you sine. Ignoring the 3, 1 over x gives you log of x. Okay. So we've got our log of x there. We've got our cos of x there. Okay. So hit pause. Copy the example down. Once you're done, hit play and we'll look at another example. Okay. So let's have a look at this example here. Find the following integral. We want the integral of cos x over sine squared x minus 2e to the power of x with respect to x. Now remember, we're doing standard functions here, so we're hoping it's going to be one of these functions that we've got at the top here. Let's rewrite it and have a look. So we want the integral of cos x divided by sine squared x minus 2e to the power of x with respect to x. So this term I think I can rewrite as it's going to be equal to the integral cos over sine squared. So I can write cos over sine times 1 over sine. Oops, I forgot my x is. X minus 2e to the power of x with respect to x. Okay, So cos over sine is cot of x, so it's the integral of cot of x. And 1 over sine, remember, is the third term, so that's going to be cosec. The third term is s. Minus 2e to the power of x with respect to x. Now, cot x, cosec x, that's a standard function. If you have it here, cosec x, cot x, it's the wrong way around, the same thing. Except we don't have any term next to the x, so it's just minus cosec x. So we go minus cosec x, and if we integrate e to the power of x, we get e to the power of x. So minus 2 e to the power of x plus our constant. Okay, and we're done. So hit pause, copy the example down. Once you've done that, hit play, and we'll look at one more example. Okay, so let's have a look at this example. It's a definite integral between a and 3a, and it's equal to log of 12. We need to find the exact value of a. Okay. So example 3. So let's have a look at the left hand side of this equation. So that's the integral from a to 3a of 2x plus 1 all over x with respect to x. I need to simplify this function first in order to be able to integrate it. So looking at it, I can rewrite it as from a to 3a as 2x over x plus 1 over x. And that's the thing that sort of sometimes bamboozles us. We forget we can split the fraction. So with the x over x, I'll just change pen for a second. The x's cancel. Makes it a lot easier. And now I have, oops, I forgot to change pen, get red. Now I have the integral of 2 plus 1 over x. Much easier to do. And that's going to be equal to 2x plus log of x from a to 3a. Sub in for a and 3a, we get 3a here, that gives me 6a instead of x. 2 times 3a is 6a plus the log of 3a. Oops, put the modular sign there. Minus 2a minus the log of a. So 6a minus 2a gives me 4a plus log of 3a minus log of a, and by the division rule of logs, 4a is going to be equal to log, oops, not equal to, plus log of 3a over a. I can cancel my a's. So I've got, that's equal to, oops, forgot to change to red, 4a plus log of 3. Right, I am going to change the color of my pen now and do this second section over here. So that implies, oops, let's change first. So if we call this part 1 and then part 2. So that implies that 4a plus log of 3 is equal to log of 12. I don't need my modular signs anymore, they're both positive. So that means 4a is equal to log of 12 minus log of 3. So I can combine and divide, so that's log of 12 over 3, so 4a equals log of 4, which means that a is equal to 1/4 of log of 4. And that's our exact value for a. So hit pause, copy the example down. Once you've done that, hit play, and I've got a couple of questions for you to attempt. Okay, so you're doing exercise 11a. Could you do just the left hand side? You could probably get away with that actually. Quite a lot of questions here. But if you're unsure, then start with the easier ones, question 1, and attempt them all. And then as you get more confident, you could skip some or do them all. Makes you better at these questions. Right, 11a page 295. Good luck.